We are live. What's up, guys? This is Dem Keys, and holy shit, dude. I went on a bit of an unintentional hiatus. A bunch of things happened. Yeah, that's all I can say. A bunch of things happened. Things got in the way, and I just wasn't able to stream. And this would have been the perfect time to use some sort of TTS system if I would have had it ready. Though I did manage to do more research on. Give me a second. Uh, my stream hasn't showed up in my. Oh, there it is. Okay, took some time. Yeah, this would have been the perfect time to, or well, these. What I think I haven't streamed for maybe 3 weeks, 2.5, 3 weeks, which kind of sucks, but it is what it is. This would have been the perfect time to use a TTS system if I had something ready. Not, I don't mean just the TTS system. Um, I have to build a system and sort of make the TTS system a part of that because the TTS system, the TTS itself is the TTS model running. That's just one component. I need to work on a sort of scheduling system because I want to set it up so I can send data in, text data. I can send text data into the app that's going to be running the TTS model. I can send the text data in through over the network and receive it in the app, and then queue it up. And then there's going to be a separate thread that um, reads the queue items one by one, or rather, there's going to be a separate thread in which I send the queue items one by one. So basically, I need to set up a queuing slash scheduling system um, to where I can handle multiple inputs. So I can keep sending text inputs into the app, and as it receives those text inputs, it's gonna add them to the queue, and then there's going to be a separate loop or well, a separate system that checks if the TTS model is currently running or not, and if it's not running, then we can send one item from the queue into into the TTS model, and then of course remove it from the queue, and then the loop kind of repeats. So the model is gonna run and it's gonna produce the audio, which will then be played, and then we're gonna send more input into the model, and kind of repeat that. So that's kind of the idea that I had. I need to set up because running the model itself is not going to be it's not going to be much of a challenge in terms of coding because I'm using Hugging Face transformers to load and run the model. So I just need to like the code setup for that is not going to be that difficult. That's the whole point with transformers. They give us sort of an easy API that we can. I don't know if easy is the right term to use there, but um, they make it so it's more streamlined to use the various models that are supported. So yeah, the idea is that there's going to be a queuing system that's going to store each of the inputs that are received, and then one by one dispatch it's going to dispatch the model, or it's going to how do I say this? It's going to dispatch those inputs. It's going to send those inputs to the model. So it's going to dispatch the model each time it sees that the model is no longer running or no longer processing something. Then it's going to send a new input into it, and then that input will be processed and output will be given, and then that output is going to be played, because it's a TTS system. So the output is going to be, what do you call it? The output is going to be audio. And so that's going to then be played on the main thread. So there's two things that I need to do research on. One is queuing in general, and then there's also multi-threading. Now in Python, we have two options when it comes to multi-threading. One is to use the multi-threading API, but they also have something called I forgot exactly what it's called, but the idea with it, the idea behind it is it's not going to be a new thread. It's going to be a new process that's going to be running. So it's going to be a separate process. And I'm considering doing that because I do remember reading that multi-threading in Python isn't true multi-threading, and it's something to do with something called a global interpreter lock or something like that. I need to read up on that and see which one I want to choose. I forgot what the other thing is called. Is it called sub-process or multi-process or something? I forgot exactly what the name is, but yeah, we have two options there. One is multi-threading, and the other is just a separate process that the thing is going to run in. And fortunately, they have both low-level and high-level APIs set up that we can use. And I'm going to go with the high-level API just to not complicate things further for myself. Uh, so yeah, I'm gonna be working on the TTS system soon, hopefully. And once I have that up and running, um, we should be able to do streams even when I'm not able to do talking streams. So I'm gonna then have AI voice streams, and then once we have the once we have a TTS model set up and running, then we can look into sort of customizing the voice and see what options we have there. But yeah, other than that, I've been busy with a bunch of things. So okay, I was gonna stream yesterday. I was gonna make my comeback yesterday, but shortly before I wanted to start the stream, I ran into an issue. So recently, I upgraded I upgraded Ubuntu on all of my Linux machines. So I have Ubuntu running on one Linux machine, and Ubuntu Studio on the other two machines. And there was an upgrade available. It had actually been available for the past couple of months. I'd just been putting it off intentionally because the update takes time, and I just didn't want to, do it at that time. So recently I decided to do that, and it went well. It went great. But something I didn't take into account was, so okay, with the upgrade, it also updated the Python version. So it installed Python 3.12, right? And because it installed Python 3.12, it removed Python 3.10. And a bunch of my projects were using 3.10 because I didn't really update Python. As a result, a bunch of dependencies broke. So when I would go into one of my older projects, and actually not even older projects, just one of my projects in general, when I would go into the project and activate the environment, the environment would activate fine. But when I would try to run anything, there would be a bunch of module not found errors, and that's because well, those modules were no longer installed because it was a new Python installation. Like it installed the new version of Python, but it didn't upgrade any of the packages that were there. And so when I tried to run the projects, I guess it didn't know where to look for the packages, or probably the packages just didn't exist anymore or whatever, but a bunch of dependencies broke. Now, this is not an issue if you have your requirements.txt file. So the requirements file is something you can generate using pip freeze. And it's great because like it'll generate a list of all the dependencies, all of the package names along with the specific versions, and then you can just give this requirements file to whoever is going to be using this environment, because you can't really transfer Python environments, or it's not the most straightforward method. You're not meant to transfer entire Python environments, at least the VN, the virtual environment type of environments. You're not meant to transfer the entire environments. What you're supposed to do is create a new environment in whatever machine you're trying to run this project in, and then use pip and the requirements.txt file to install all of the dependencies. So the only thing you need to do is create that new environment and activate the environment, of course, and then run pip. I think pip install, and then you give the R flag, and then the requirements.txt file. Okay, now here's a problem that I ran into. I don't think I had the requirements.txt file for one of the projects that I was trying to run, and that project had a couple of things, including Streamlit. And Streamlit is a massive package. Like it has a bunch of different dependencies. I had a couple of other things as well, pandas, NumPy, and stuff like that. And well, I wasn't able to get pip to work either because pip was also giving module not found errors, right? So after doing a bunch of research, I found a sort of messy way to get all of the package names, all of the possible package names, and then I generated a requirements.txt file out of that and installed it. Uh, and I'm probably gonna have to do that for a couple of my other projects where I don't have a requirements.txt file. So, lesson learned: always generate a requirements.txt file. Just after you've installed new packages in your project, just generate a requirements.txt file. It's one line of code. It'll generate one file, and it's going to save you a ton of headache if you ever decide to upgrade Ubuntu. Because I mean, or well, okay, not just upgrade, not just upgrade Ubuntu. If you decide to update your Python version as well. So like if you decide to go to a higher version of Python, you can't use the older version that your environment is expecting, because it's going to be pointing to a bunch of things that either don't exist or cannot be used or whatever. So yeah, lesson learned. Always generate a requirements.txt file. This isn't really a big problem for projects that you are getting off of GitHub, or that you have on GitHub already, or projects that you've stored somehow on GitHub, because usually when you do that, you're going to generate a requirements.txt file. Like you need that, because without that, just putting the Python environment up there, it's not going to do anything. You need the requirements.txt file. So if it's any project that you've gotten off of GitHub, or any project that you have on GitHub, there's a decent chance that you're already going to have a requirements.txt file. So all you have to do is delete the environment, create a new environment, activate it, and then just install those packages. But in this specific situation, I didn't know that this was going to happen. And so for some of my projects, I don't have a requirements.txt file. So things are going to be a tiny bit messy in terms of, getting them to work again. But I did find a sort of suitable solution. So that's great. What else? What else have I been up to? I have been, okay, so we learned how to build, train, and test a feed-forward neural network specifically for classification purposes. And since then, I've been trying to wrap my head around what exactly is going on within the network, or more specifically, how the network understands the input and how it processes the input. I'm not trying to understand the calculation that's happening. I'm trying to understand exactly what the network is understanding from the input, if that makes sense. I'm trying to understand what the network is understanding from the input, and in each layer, how the input changes, and how each layer affects the input in order to, influence the final output, and how the number of neurons in each layer can change how things are handled. So I'm trying to understand how the network understands the input, because so far I haven't really understood that. Like I understand that, okay, I can I can pass this input in, like I understand conceptually what's going on, and even from the math side of things I understand. Actually, you know what? No, I understand the math side of things. It's just simple linear transformations that are happening, and then there's ReLU functions in between. So I understand the math side of it. What I don't understand is, I guess, conceptually. Like I'm trying to, I don't even know how to explain it. I'm trying to understand, I don't even know how to explain what it is that I don't understand. But yeah, I've been trying to do research and trying to understand how the neural network sees this input, and how each layer changes the input. Oh, yeah, okay. Feature extraction. So I've been trying to understand what kinds of features the neural network is extracting, or not the neural network, each layer of the neural network, what kinds of features each layer is extracting. And I'm getting somewhere with it. There's still quite a bit of reading that I have to do. Fortunately, LLMs are able to help with this. I have a bunch of text written down from, it's on another system, so I can't show it, but I can ask the same question. Um, yeah, I can ask the same question to a neural network here. I can probably do a whole separate stream where we just, I think one of the previous streams, I was trying to do exactly this. I was trying to understand what exactly the neural network understands from the input. Other than that, I also need to do research on what else we can use the neural network for. In what other ways can we use the neural network other than just classification? And also, in terms of classification, what different ways can we use a classification neural network in, if that makes sense. But yeah, mostly I'm trying to understand all of the other ways that I can use a feed forward neural network. What other problems can I solve? Because I'm sure there's tons of other problems that can be solved using a feed forward neural network. There's quite a bit for me to explore here, so I'm taking my time with it before I move on to convolutional neural networks. Um, but yeah, dude, I've been doing research on that as well, bit by bit. I think the next stream I might just carry on doing that research. I need to remember to write down the question itself. Because I'm not asking Gemini, which I think I should be asking Gemini. Yeah, maybe I should ask Gemini this question instead of DeepSeek, or I could ask both. Because one of the conversations that I had was with DeepSeek, um, and because that conversation disappears after I refresh the page, so that's why I have to, like, if I get a a particularly well structured output and much more informative output, then I kind of copy that entire massive essay and post it, well, paste it. I copy it and paste it into like a notepad file so I can then read it without having to go to that web page, or I don't lose it if I refresh the page. But with Gemini, I can actually save the conversation as well, so I don't need to worry about losing it. Not only can I save it, I can also refresh the page, and it's going to maintain that conversation. That's something I really like about Gemini. That's one of the many things that I like about Gemini. But yeah, yeah. At some point, I need to write down. No, you know what? Actually, I can't ask Gemini on. Well, no, I can ask Gemini on stream. I was about to say that I can't ask Gemini on stream, but then I have logged into Google AI Studio on stream. Well, I haven't logged in on stream, but like I use AI Studio, which is in which I am logged in. I use that on stream. So, I mean, I could technically just ask AI Studio instead of Gemini. Um, but yeah, yeah, that's oh, something else that I'm excited about. I finally learned how to export um a feed forward neural network to the Onyx format, or rather, I should say, a PyTorch model to the Onyx format. Not only did I learn how to export it to the Onyx format, but I also learned how to run an Onyx model in in an Onyx runtime. And something exciting that I have lots to explore in is this. Oh shit! I didn't realize it's okay. Give me a second. Give me a second. I need to load it up. Um, I thought I had the thing loaded up, but then I forgot that I'd restarted my system, because of which the thing is not there anymore, which is fine. I just need to reload. Actually, I could have showed it. I didn't, for this specific thing. I didn't need to switch to. Um, that's fine. Okay, so let me show you guys real quick. So okay, you guys already saw the thing. Whatever, dude. It's fine. So we're going to be using Netron, and I'm just going to load up one of the models. I think this one is fine. Give me a second. I want to see what that looks like on stream. Um, well, okay. So I'm on a bit of a delay on stream, so that's why it takes some time. I just wanna and yeah, okay. So this is the neural network in Onyx format. So I created a simple. I didn't want to use the bigger neural network. I wanted to make a smaller sized one, just so just so it was a little easier for me to, do calculations and stuff if I needed to. Um, I basically used the same old neural network architecture, which was used for classification. But instead of having, 600, 700 neurons, it only has like 2 to 4 neurons, and the rest of the architecture is the same. So this is great because in this way we get to see all of the operations that are happening. And dude, I also had like a bit of an adventure in terms of PyTorch versions and stuff like that. But like, I mean, I'm not going to go into that. There was a bit of a confusion about like which version of PyTorch Kaggle Notebooks is using. It it turns out that the notebook that I was using, I had created it a while back, and in the settings, I had set it. Well, I didn't set it. The default setting is to just never upgrade the packages. But then you can also set it to upgrade the packages to the latest ones, or well, use the latest version available. So you could be using the latest version of, for example, PyTorch. If you have been on PyTorch 2.3 and then, you know, they suddenly jump to 2.4 or 2.5, you can have that setting on so it'll like automatically start using the new version and there's no headache for you. In my case, I just decided to create a brand new notebook just because the old notebook had like a bunch of other stuff in it. So I was like, let's just start a brand new thing. So I recreated the neural network and I exported it to the Onyx format, and this is what it looks like when you run it in Netron. Shout out to the devs behind Netron. It's a huge help for exploring Onyx graphs, and I'm gonna be visiting this quite a bit because Onyx. I mean, we've spoken about Onyx on stream before. It's great. Like the Onyx runtime and Onyx in general makes it so your your PyTorch model becomes portable and also multi-platform. So any platform that implements the Onyx runtime, and the specific version and offset version and all of that stuff, as long as the versions match, as long as it implements the Onyx runtime, you can you can export your PyTorch model to Onyx and run it on whatever that platform is. And in my case, I'm not just gonna be running it in a Kaggle notebook. I'm also gonna be running it in Unity, more specifically using the Onyx runtime through Unity Centis, because they have their own implementation of the Onyx runtime there. So yeah, I'm excited for that. I'm excited for that. That's one of the reasons why I wanted to familiarize myself with exporting to Onyx and then running an Onyx model in the Onyx runtime. Um, and I also wanted to get an idea of the different operators that you'll find, the different operators, the different functions. Like for example, okay, so let's explore this. There was also a casting operator which doesn't seem to be showing up right now for some reason. I'm not sure why that is. Give me a second. Let me. Yeah, yeah. I was just trying to remember the thing. Let me open up the MNIST model. The MNIST model had it. Yeah, it's right here. This cast operator. This was a tiny bit confusing. Oh, oh, you know what? Yeah, I think I realized what it was. Yeah, okay, okay. So this is the MNIST model, right? Um, in the MNIST model, here's what we were doing. We would first flatten the input that we get, Then we feed that input into our linear ReLU stack, which was basically a linear layer, a ReLU layer, another linear, another ReLU, and then I think another linear, and then we get the output. So the last linear was basically our output layer, I guess you can say. I'm not sure. But yeah, that gets kind of broken up into multiple different operations here. So here we have our flatten operation happening. You can see we pass in a 1 by 28 by 28, and then that gets flattened, and then what's returned is a 1 by 784 because there was a flatten operation. And initially I was a bit confused, and this is something that I love about this Netron app is that you can explore every single node and every like connection and stuff. So there's like tons of information that you can get about the entire graph, not just the nodes, but also the data in the nodes, the input, or even the output, I guess. The attributes basically of each of the nodes. It's great. It's awesome. So this is our flatten operation that's happening. And cast, I believe it's converting it from float to maybe int64. I'm not sure. I need to explore this more. But yeah, cast is basically typecasting. It's converting it from one type to another. I'm not sure why it was doing it here, why it was converting um, to N64 here. I think we need to explore that a bit. Yeah, I think I need to explore that a bit. I'm trying to remember if there were any floats in the input, because the input was basically grayscale values. I think it was grayscale values between 0 and 255, which doesn't have to be a float, right? So I think that could be one of the reasons. Maybe I'm not sure. Either way, it could be something else as well, but yeah, we have the cost operator. Then we have this transpose, which so this was one of the confusions that I would usually have. So okay, what happens? Let's talk about this gem operation real quick. This gem operation, it can be used for a bunch of different things, but in this case it gets used for the linear transformation. This is our basic linear transformation where we multiply the input with the transpose of the weight matrix, and then we add the bias to that result. This is our basic linear operation, and the transpose here is for the weight matrix. So the same thing happens later on as well with each of these linear operations, because we are taking the transpose of the weight matrix. So it does the transpose first, and then it passes that in here. And it's really interesting exploring each of these nodes, and um, through exploring each of these nodes, understanding the network, because it doesn't change the structure of the network. It just breaks down the network's operations into multiple, I guess you can say, smaller operations, which in this case, actually I don't even know if I would say it breaks it down into smaller operations. I think it just breaks it down into operations. That one network, it converts that one network's group of operations into Onyx related operations. And in Onyx, they have implementations for the various. Do any of these have like a link to the Onyx docs site? Probably not. Yeah, probably not. But yeah, on the Onyx site, there's documentation for each of these nodes, so you can get a good amount of information for each of these. And they have for convolutional neural networks, they have for I think recurrent neural networks as well. I haven't looked for transformers, so I'm not sure. I'm It probably has. It probably has the required nodes for that as well. Um, why was I why was I talking about this? I forgot why I was saying this, but yeah, it's yeah. I think I was correcting myself that it doesn't break it doesn't break it down into smaller operations, though it kind of does in certain cases. It does it when it's required. Like for example, in this case, um, transpose is something that gets added in there. This gem is basically, I think it stands for general matrix multiplication. I don't remember the full name. And it's kind of interesting the way that they've set this thing up, because the formula that gem or gem computes is this. Give me a second. Let me type it out here. The formula that it computes is a as in alpha. So let me just type alpha. Alpha multiplied by a multiplied by b multiplied by beta. No, multiplied by, no, plus beta multiplied by c. And in this specific case, it seems like they're being used as flags in a way, but not really flags. They're being used as multipliers, but to a certain extent, I was kind of seeing them as flags as well. So I was initially kind of confused about what exactly is going on here, because my understanding was just, it's going to be A multiplied by B plus C. So this is our input multiplied by the transpose of the weights plus, well, C. C is the bias. That was my understanding of this. Um, what was I saying? Yeah, yeah. Um, but then in this case, they added this alpha and beta. So I was like, what if they're using them as flags? Because alpha and beta are like individual values. They're not matrices. They're individual values. They're floats. So I was like, well, okay, floats or ints. I don't know. I'm gonna say floats, but they're scalar values. They're individual values. They're not matrix. They're not matrices. So I was like, okay, how is the multiplication really happening here? The only way I can see it happening is if we are doing like an element wise multiplication, but not really element wise. It's like that one value is multiplied by all of the elements in, the next matrix. So it turns out what's happening here is alpha and beta get used as multipliers to be able to scale the value, and that is useful in certain situations that I haven't encountered yet, because I'm doing very basic stuff, but like in various situations it does get used. But in this specific situation, it's just being used as a multiplier to say that yes, this value is used here. So here we have alpha, the value is 1, and beta, the value is 1. And trans A and trans B, these are basically flags which say that um, we are supposed to use the transpose of A or the transpose of B. In this case, though, we are not using transpose of either of them because the input doesn't need to be transposed. The weight matrix does need to be transposed, but that's already happening here, so we don't need to transpose it in here. And then that operation is done, and then it gets passed into the ReLU function, and then that gets passed into the next linear layer. So the gem operation is basically our linear layer. Then we have the ReLU layer, and then the next linear layer, and then ReLU, and then the next linear layer, and from that we get our output. Um, yeah, that's what I've been up to with Onyx. It's been exciting. I've been busy, dude. I've been busy. And dude, I've I also kind of want to get back to making YouTube videos. I have ideas. Not And the great thing is not just they're not just tutorial ideas. There's also just I feel like I'm gonna make videos on like deep learning and neural networks and stuff. Not tutorials specifically, but just like stuff that I find interesting. And I'm probably gonna post them on my main channel, a channel on which I haven't posted in years. And yeah, I have some tutorial ideas as well, which I'm gonna be working on and then recording and stuff. And then side by side, I'm also gonna be, obviously streaming. Um, and also learning, continuing learning. So I need to get past feed forward neural networks and move on to convolutional neural networks, and then move on to recurrent neural networks. There's gonna be a good bit of stuff to explore. And once I've learned these, I also want to go into transformer based neural networks, transformer based architectures. I need to study the components of that as well. Um, Hold on. Give me a second. I want to show you guys what exactly I want to. Hold on. Let me. Okay. Let's say torch.nn. Yeah. Okay. I think that's it. So, at the very least, I want to explore as much of everything that's in this area, I guess, in on this page, as many of the layers, as many of the different types of layers that I can explore, and as many of the different types of functions, the nonlinear activation functions, for example, that I can explore. I want to explore as many of them as I can, because in this page, on this page, we have a list of stuff, a list of all the different components that make up more complex architectures. That's why I want to explore as many of these things as I can. I don't really want to, go through the entire page, but that's kind of why I'm grouping it into feed forward neural network, convolutional neural network, recurrent neural network, and then transformer based neural network. Because like these four groups alone, they will expose me to various components that are available on this page. And then, of course, there's much more complex architectures that we can explore through. I need to write those names down. One was Tim, and there was another one available through PyTorch, I guess. I don't remember. I think it was available through PyTorch. Where was it? Torch Vision. I think it was in Torch Vision. Probably, yeah. I think it was in Torch Vision. Now, where's Torch Vision here? Let's look for Vision. Vision layers, vision layers, vision layers. Okay, give me a second. Torch Vision. Let's search for that. And okay, that is not going to be helpful. So I'm going to look here. Torch Vision. Torch Vision documentation. And while we're here, we might as well open up Tim as well. I'm just give me a second. I'm just trying to remember the two things that I had kind of discovered where I was like, okay, we need to, you know, okay, we can take a look at Tim's documentation. Yeah, yeah. I think this is good. Okay, um so in here, I believe they have a couple of different architectures. I can't remember where it was. Was it even here? I don't remember if it was here. But yeah, in Tim they definitely have like an entire list of uh architectures and even like pre-trained models that you can use. So I'm assuming you get the weights along with them as well if you want, or you can just use the architecture alone and train the model on your own data. Is it here? Yeah, I think this might give an I well, this is going towards the API. Um, hold on. I think there was a link to the repo. Find all TIM models here. Right. So let's take a look at, or let's, no, you know what? Let's not. Wait, it says TIM specifically here. I didn't realize this was part of that this was one way that I could research these, or I didn't realize this was one way that I could actually search. Um, I guess it's because I've never looked for libraries. Most of the time when I use the search function, I'm looking for models or data sets, but usually it's just models. But yeah, this is the repo, and in here they have a proper list of all of the stuff that's supported. Yeah, yeah. So at some point I do want to do. There was another thing, but I can't remember where exactly it was. Was it this? Models and pre-trained weights. The torchvision.models subpackage contains definitions of models. I think this might be it. It had a couple of different models in it. Stuff like I think ResNet was part of it. Yeah, yeah, it mentions ResNet here. ResNet 50. ResNet. Okay, okay. But yeah, um, these two things I definitely want to explore. One is torchvision.models and one is, well, Tim. In Tim, there's like a whole bunch of different models. But this is after I've finished learning about, well, I mean, so far we've finished learning about feed-forward neural networks, but I also want to finish learning about convolutional neural networks, recurrent neural networks, and transformer-based neural networks. So after that, we can go into these architectures. I also want to eventually start exploring or start doing research on, how do I say this? I want to start doing research on like architectures that solve specific problems, if that makes sense. Yeah. So, for example, if I wanted to train a language model, for example, then what kinds of architectures do I have as options? And what are the pros and cons of each different type of architecture? How I should approach building uh, the specific architecture required for the specific problem that I'm trying to solve. Because I don't want it to be a situation where I'm memorizing architectures. I want to understand the components that are being used in each architecture, and understand why they are being used, so that I'll be able to reason, or come up with my own solutions in the future when I need to, build my own model to solve a certain problem. Because there's a bunch of different problems that we can solve. Um, Hold on, let me show you guys. So these are some of the tasks that you can try to solve, or these are some of the problems that you can try to solve using different neural network architectures. And for each of these different types of tasks, there's going to be a different architecture that fits well. The interesting thing is, with each of these tasks, there's probably also going to be multiple architectures. Like when you look for the different models that are available for each task, many of them are going to be like following their own specific architecture to solve the problem in their own way. Some problems that I would definitely like to solve are, first of all, well, okay, some tasks that I would like to accomplish using different neural networks. Um, or how do I say this? Yeah, some tasks that I would like to perform, I guess you can say. What am I trying to say here? I'm trying to say that some of the different architectures, like I want to build different neural network architectures to solve, to accomplish different tasks, right? Now I'm starting to lose my train of thought. Where was I going with this? Okay, I forgot. But yeah, my point with this whole thing is, oh yeah, I was talking about like some of the things, some of the problems that I want to try and solve, some of the tasks that I want to accomplish using different neural networks. Some of them are text to speech, speech to text, um, language models, and I also want to explore computer vision. What exactly in computer vision? There's a bunch of different things that I can explore there. Um, some ideas that I do have are stuff like body pose estimation. I want to see how well I'm able to solve that problem. I would like to create a very lightweight model that also performs really well. Um, but yeah, I'm gonna have to see how. Actually, that would be a good thing to do research on, an interesting thing to do research on. I mean, even language models, and I'm definitely interested in language models, because there's a bunch of things that I wanted to explore. Give me a second. Yeah, there's a bunch of things that I wanted to explore in terms of language models, because there's a lot of like problems that I wanted to try and solve. Or well, yeah, but they're not really problems. Well, I mean, you can call them problems for the sake of saying that you're trying to find a solution to them, but really there's a bunch of different features that I wanted to do research on. Stuff like long-term memory for language models. Stuff like giving a language model giving a language model a personality. Sorry, giving a language model a personality. Um, what else? A bunch of things actually. Like okay, stuff that you can do with the much bigger language models currently. Oh, another interesting thing would be creating. So agents is an agents are a topic. Agents is a topic that I want to explore at some point in the future. Um, there's also agent to agent protocol. I think that's what it's called. A2A. I don't remember. It's a protocol I think developed by Google recently. Yeah, yeah. It's the agent to agent protocol by Google. I can bring it up here actually. So there's a GitHub repo for it, and there's also their developer blog page thing. Okay, we can look at both of the things. Okay, so um, this is it. Agent to agent protocol, an open protocol enabling communication and interoperability between opaque agentic applications. The agent to agent protocol addresses a critical challenge in the AI landscape, which is enabling Gen AI agents built on diverse frameworks by different companies running on separate servers to communicate and collaborate effectively as agents, not just as tools. A2A aims to provide a common language for agents, fostering a more interconnected, powerful, and innovative AI ecosystem. So, what's interesting about this is I've noticed a bunch of other platforms starting to implement this with their own systems. I can't remember exactly which platforms there were, but I remember seeing on Twitter about a bunch of different um, platforms that have tools in, how do I say this? So like on Twitter, I follow a bunch of AI people, a bunch of people that post AI related news, and these people, one of them had posted about a platform that a, a pretty big platform. I can't remember which platform. Maybe it was OpenAI. I don't remember. I don't remember. Yeah, I can't remember which one. Or maybe it was Microsoft. Hold on. Now I'm curious. Microsoft A2A, because this had become like a news kind of thing. Yeah, I think it might have been Microsoft. Maybe it was yeah, yeah, that's the news. Okay, I'm seeing the TechCrunch article right now. It says Microsoft adopts Google's standard for linking up AI agents. So this is just one example. I'm sure like a bunch of other platforms, and this is great because this is an open protocol, right? So everybody can study it. Everyone is free to implement it. No one really controls it. The community decides kind of. Well, okay, I don't know what exactly is the. Yeah, I shouldn't say in this case that the community decides it. because I think Google is still in control of it, but it's an open protocol. So wait, how are the decisions made? So okay, contributing. We welcome community contributions to enhance and evolve the A2A protocol, contribution guide, private feedback, partner program. Okay, so the community can suggest improvements. I don't know what the exact system is that they have, so I don't want to talk too much about it without knowing. But I'm assuming the community can contribute towards improving it in whatever way they see fit. I'm sure there'll be like a sort of discussion that takes place between various contributors and stuff to decide whether somebody's contribution can benefit this or would it make it take a step back. So would it be a positive or a negative, or there's going to be like discussion threads and stuff. Okay, my point is this is great. It's great when there's like an open source protocol and multiple platforms and frameworks and stuff just collectively decide to use that protocol. So then it becomes like a standard. And then a bunch of people are able to build their products and services and stuff around that, keeping that assumption in mind that hey, um, let's say in this case we're talking about communication between well, communication and interaction between agents. So in terms of interaction between agents, there's a multitude of ways that you can come up with in order to have interaction. And each way is going to have its pros and cons depending on what the situation is. However, every the fact that everyone can implement their own separate way of communicating means that everyone is going to do that, and then agents built by one person won't be able to interact with agents built by another person because they're both following different communication protocols. So if you have like one standard communication protocol that everyone has collectively agreed to follow, um, you can what do I even say? Like you can make progress. That's what I'm trying to say. You can make more progress once everybody collectively agrees that hey, like for example in this case, now that we have this protocol, if a bunch of different people decide, if a bunch of different big companies and big platforms and frameworks and all decide to implement the A2A protocol, and they decide that okay, our agents are now going to be using the A2A protocol. I just lost my train of thought. What was I saying? I was saying that why it's great to have like a standard, especially an open source standard that a bunch of people implement, and then because of that they're able to have because of that they're able to make assumptions that hey, okay, this thing is going to be working in this way, and so we can build our products and services around this thing. And it also, like in this case at least, it makes communication and interaction between agents easier regardless of what framework they are built with, what platform they're running on, and all of those different extra details. None of those things are going to matter because when it comes to communicating with each other, they are still using this standard protocol. And that's not to say that this is going to be the only protocol that's used. This might be one of multiple other protocols that are going to be used in the future. But the fact that now we have this one thing that's slowly being used by more, or slowly being accepted by more and more people, that's great. Like we're going to see more progress surrounding this. So I need to look into the concept of agents in general. I think I need to start with that before I go into the more complex stuff, because I've been seeing about AI agents. I think ever since ChatGPT, well, no, it was a couple months after ChatGPT, where people started developing these agents that could handle the tasks for you. Of course, there would be a bit of programming involved there, but you could program the agents to use different models in different situations and stuff like that. So the idea was to slowly make them autonomous. And of course, we are not really at that point where we can be truly autonomous, like completely, or the agent can be completely autonomous. But for solving specific problems, they can be autonomous to a certain extent. And the concept of agents kind of helps with that. So I want to explore the idea behind agents and see how to approach it. Okay, so I think that's going to be it for today's stream. I'm going to end here. I'm going to try and stream again tomorrow. Probably tomorrow we're going to be carrying on learning or trying to understand feed forward neural networks, or more specifically, trying to understand how feed forward neural networks understand the input. I'm gonna craft the perfect question for DeepSeek, and then tomorrow I can just paste that question into, well, DeepSeek on stream, and then we can read the entire thing on stream. And hopefully we get a bunch of information about, how these neural networks work, or how these neural networks understand their input. Because I have the information already. The I have this like big essay that I've copy pasted, but it's on a different machine. It's not here. Oh, you know what I could do? I could transfer this text. That just occurred to me. I could transfer this text and then paste it in this Kaggle notebook, and then we can just read that. So, because I'm going to continue reading this text, though I think if I just sit down and read this for some time, I'm going to finish reading it, and then I don't need to do the whole copy paste thing. But I still have like lots of questions about, what exactly, what kinds of features is each hidden layer in a feed-forward neural network extracting? And how do we visualize all of that? Because, like, it seems like, okay, it's extracting features. We say that conceptually, it's extracting features. But then all we are seeing is numbers being pulled and then being transformed into something else. So those features get extracted and then get transformed into something. Or, well, the transformation is basically the feature extraction. And then you extract more features out of that by passing that into the next layer. Okay, you know what? I'm gonna stop here. So I'm gonna end the stream now. I hope you guys have a nice day. Thanks to any lurkers who might have been, well, lurking. Um, Hopefully I'm able to stream tomorrow as well. Hopefully I'm able to do a talking stream tomorrow. But yeah,